All right. To kick us off today, I'd like to welcome Sherry Wang, Senior Data Scientist at Cars.com, where she owns several high revenue impact machine learning models. Today, she's here to share the experience on how at Cars.com they have conquered the hurdles that a machine learning engineer or data scientist has to overcome to bring a model from ideation to production, especially on the cloud, by creating the open source tool Skelebot, and she hopes to inspire you to apply it to solve your own problems as well. So welcome, Sherry. Please be sure to ask your questions in the Q&A panel, and Sherry will be answering them at the end of our talk. With that, I'll turn it over to you, Sherry. Thank you.
Hi, everyone. My name is Sherry, and I'm a data scientist from Cars.com. Today, I'm going to be talking about improving machine learning team productivity with standardization and automation. Mostly, I'm going to introduce a tool that we build in-house, but it's open sourced on GitHub called Skelebot. I'm going to go over these kind of things. First, I'm going to give a brief introduction about myself, and we're going to talk about what is Skelebot, how do you use it, and why do you want to use it, or at least why we chose to develop and use the Skelebot. A little bit about me. I've been doing data science for more than 6 years now in different industries. And currently, I'm working for Cars.com, solving mostly core business and search-related problems. And my passion is to use data science for social good. You can find me on LinkedIn or Medium. Before we start going into what is Skelebot, I want to maybe kind of talk through a simplified machine learning development process. At least this is a process that we kind of follow at Cars.com. So we use Spot instances on AWS. Whenever we want to develop anything, pretty much every day we just start by spinning up a Spot instance, request the resource that we need, and then we would have to create our own development environment. This pretty much means we're gonna install the languages. Most probably it's gonna be either R or Python. Need to install all the dependencies for the projects we're working on. And for most of us, we use Jupyter Notebook as our IDE, at least in the exploration phase. So we would have to set up Jupyter Notebook on the instance. And then it's where the fun starts. We do a lot of data explorations, and we do feature engineerings, and we're probably gonna try different models and evaluate them. Eventually, what we're gonna have is probably something looks like a pipeline for training and probably also for inference. We're gonna have multiple different artifacts, and we go to the last step. For us, we would usually hand off to the engineering team with some Docker images and also some artifacts. Maybe it's some models we trained or some categorical encoders we saved. So this is kind of a process we go through. And there are many things that we do repetitively across many different projects, like publish the image or publish the artifacts. There are also things we do almost like repetitively every day, like creating the environment on the Spot instance we create. So that's why we created the Skelebot tool. That it's pretty much a command line tool that we use to develop and execute all our machine learning project in Docker. And like I mentioned, the main reason for that is we want to automate a lot of these repetitive tasks we do every day. We also want to do it in a unified and consistent interface. It's an open source tool, so you can find it on GitHub. But what I really meant is if you look at a Skelebot managed project, you will see that there is skelebot.yaml in that project. This is specifically to kind of specify all the things you want Skelebot to do. And on the other hand side, you will see that this is an example YAML file where pretty much you just says everything, you configure Skelebot so that it will do things that you want it to do. We're going to go through it in details. But I also want to show what do I mean by a unified interface. So this is what happens when you already configure it, like I showed before, using that YAML file, and you can run skelebot-h, which means you want to get the documentation, or like you want to get the helper documentation for this project. And this is what you see. So this is kind of like an Aris example projects, but you will see that it has the project names. It tells you what version it is. And also here you will see that you have a bunch of Skelebot command. You can do Skelebot load data train or score, which is specific to this project. These are the steps I mentioned that you build probably in your training pipeline or inference pipeline. There are also things like push or pull artifacts that are pretty much repetitively done across many different data science projects that Skelebot are just able to do for you if you configure it right. So we already kind of know what Skelebot is. I want to kind of go a little bit deeper, still using the simplified development process as an example to show you exactly how you can use Skelebot. The first step, the creating Spot instances, is outside of what Skelebot would do, but the first step after creating instance is creating this development environment pretty much every day. You can use just one line of code, Skelebot Jupyter. And under the hood, Skelebot is gonna create a Jupyter or set up a Jupyter notebook inside of Docker using the dependencies you specified in your YAML file. So in this case, I'll go from the bottom to up. You have two packages that are, by the way, this is a R project, so you can specify your language as R. And if you use Python, you can just say Python. You can even specify Python 3.7, 0.8, 0.9 Python version. So Skelebot will take care of that for you as well. Going back to the dependencies, so you have two packages that are R package from Chrome. And you can also specify dependency that you want to install directly from GitHub this way. You can also specify local files that are developed maybe on your machine that you're using for a different project. But in general, you can specify any type of dependencies, give it the source name and the package name. Skelebot will be able to install that for you. So this will ensure you every time you run Skelebot Jupyter, you will get a Jupyter notebook running at the port you specified in the folder you specified with the same dependencies and languages. So next up, like we mentioned, you probably are going to be developing almost like a pipeline. Instead of using a formal managed pipeline manager, Skelebot is more like a lightweight way for you to be able to utilize Docker under the hood and build a pipeline. So for each of the steps you do, you can specify that in the Skelebot YAML file under the jobs portion. Pretty much you just give it a name, and there are many things you can configure it. If you are reading data from local file systems, or if you're, for example, writing out your model artifacts, you probably want to mapping it. It's kind of like a Docker kind of term, but it's really easy even if you don't understand what it is. You can still specify your mappings here, and Skelebot will take care of it for you. Of course, you can specify your arguments and parameters as well. So how you want to run this pipeline, right, is just really through one line of code again. In this case, I'm kind of saying that I want to run a training pipeline. And a couple steps in my training pipeline is query, wrangle, pretty much I'm doing some sort of data pre-processing or feature engineering. and then I'm training my models. And I'm saying that, hey, I want to save my models at this output folder called results. By running this line of code, Skelebot, again, will be able to create Docker images under the hood for this entire pipeline to run inside of Docker, so that you will ensure you'll have reproducibility. And this also helps a lot of the company, or at least at Cars, eventually we're going to be handing off a Docker image. So if you're already training everything inside of Docker, it will be a lot easier when you need to move from your development to your production. So when you already have your pipeline set up, you have your Docker images pretty much built, and also you have your artifacts built, what you want to do is you want to push it to your registry or your repositories. And here again, I'm just specifying where my repositories are, the URL and repo, and also my path. As well as at Cars, we use ECR. So here you see registry, we're using AWS ECR, specify your region and profile. Then you tell Skelebot that, hey, I'm gonna save my model as an artifact, give it a file, and also some other parameters you can kind of specify. With this 2-line of code, you will be able to push your artifact to Artifactory and also publish your Docker image to the ECR. I only kind of scratched the surface of Docker, of Skelebot's functionalities. There are a lot more things we can do with Skelebot. If you go to the documentation, you'll find all these other features you can use Skelebot for. So really, why do we want to use Skelebot? For us, there are actually a couple reasons. First, we are a data science team that have really diverse background, talents that have diverse backgrounds. So to us, some of us are not really familiar with Docker, but we want to be able to use Docker and take advantage of that. And using Skelebot allows us to almost abstract away all these details about Docker and allow people to start using Docker without knowing too much about it. All you need to do is specify your configurations in that YAML file. And the second benefit from using Skelebot is automating a lot of these repetitive tasks. As I already showed in our simplified example, there are many things we do across different data science projects or even within each individual project. And we are able to do that with really just 1 line of code that helps us to improve our productivity. And the third benefit comes from consistent interface. As I showed before, all our Skelebot managed projects, you run them in the same way and you configure them in the same way. They have really standard documentations. So that makes knowledge transfer really easy. We can easily just go to a new project and understand how to run it right away. We can easily go to a new project and run the documentation and know what to do next easily. But I also want to mention another point that benefited us a lot beyond just all these functional benefits. We start to get to a point where we need to scale. A lot of the things we did before are not working anymore. We need to adopt better engineering best practices. And being able to create and even use a tool like Skelebot help us to identify and automate these repetitive steps. We start to have a mindset that if we're doing something more than 3 times, we should probably find a way to automate that. Another thing about Skelebot is it's really easy to extend the functionalities. You can just create plugins really easily. So that helped our team to create plugins for test plugin for monitoring, or plugin for setting up dashboards easily. Being able to contribute or maintaining an open source tool like this is also helping us to learn and adapt engineering best practices. So with this tool, we're able to have almost foster a culture to strive for engineering excellency. With that, I want to thank you for tuning in for this talk. And we are always looking for new users and even new contributors to Skelebot. And I would really encourage you to check out Skelebot on our GitHub.